Videos about a past exam question on the Suvat equations. Now, when there's lots of information given to you like this, I'd always recommend you highlight all the key information. So it's talking about a long jumper, and it says that halfway through the jump is where position A is. So this position A, where the motion starts for our whole question, is halfway through the jump, and position B is where contact is made with the ground. And it says that athlete is traveling horizontally at A. So why is that important? Well, if the athlete is traveling only horizontally, then that means that vertically the athlete will have zero velocity. And that brings me on to the first point. Sorry, I've got a blocked nose that I made here. The initial velocity is zero in the vertical part of the motion. So we can use the Suvat equations to do this question because we're taking the motion from A to B. At A, the person is at the height of their motion, meaning they're at their maximum height, which is why the vertical velocity is zero. V in this case is the final velocity at B when the contact is made with the ground, sorry. We don't know that actually, and it won't be zero because that's the velocity after everything's complete. Final velocity actually stands for the velocity just before it hits the ground. Try not to get confused with that. Now vertically, we also know that the person is falling 1.2 meters because it mentions that their center of mass falls 1.2 meters. So that's the displacement. We also know that vertically, a person would go downwards due to gravity. So the acceleration is due to gravity, and that's a value of 9.8. And you want to find the time in between A and B. Now with these questions, Suvat questions, there'll always be 3 known variables and 1 unknown variable. When there's this common, then you can use one of these 5 equations. In this case, the equation involving S, U, A, and T is this second one here, S equals UT plus half AT squared. So let's substitute these numbers into that equation. So S is equal to 1.2 is U multiplied by T, which is 0 times T, so that's just 0. I'm not even going to include that. Plus a half times A, which is 9.8 times T squared. We can simplify this further straight away because a half times 9.8 is 4.9. By the way, you could have used 9.81. Either one of those is fine. From here, you divide both sides by 4.9 to get that T squared is 1.2 over 4.9. And then square rooting both sides, you'll get the value of T. I don't have much space, so I'm just going to type that into my calculator, and you'll get that it's 0.49 seconds. Great, let's move on to the next part of the question. So I've given another hint here that the horizontal distance is horizontal speed times time. Why is that the case? Well, it's because in air, we can always assume that the horizontal acceleration is 0. This will always be true in air unless it specifies otherwise. It's something that I realize comes up in the specification quite a lot, so do take note of it. When acceleration is 0, that means that a half AT squared is 0, so you can just use S equals UT, or distance equals speed multiplied by time. So the horizontal displacement that's moved is the horizontal speed that it travels with, and because there's 0 acceleration, that velocity stays constant horizontally. And you multiply that by the time taken of the motion from A to B, which is what we found in A part I, 0.49. Multiplying those two together, you'll get 4.2 meters. Lastly, in B part I put another hint that you have to use Suvat here. The athlete in the image slides horizontally through the sand at a distance of 0.35 meters before stopping. So, do you remember I said how horizontal acceleration is 0? That only applies in the air. Now that the person's landed in sand, the person is decelerating horizontally, because otherwise they wouldn't go from a velocity of 8.5 to just stopping. You have to decelerate. It says calculate the time taken for the athlete to stop. So again, let's write out our Suvat. And in order to use one of the equations, again, we need 3 known variables and 1 unknown variable. The displacement that's moved is, well, it mentions that 0.35 meters is moved before stopping. Its initial velocity that it comes in with horizontally is 8.5, because that was its horizontal velocity, the whole motion in the air. If it's stopping, then its velocity horizontally would be 0, and we want to find t. So the equation involving s, u, v, and t is this fourth one here. Let's substitute into that equation. So we have s equals v plus u, same thing. So 0 plus 0.5, oops, sorry, 0 plus 8.5, multiplied by t, which we're trying to find, all divided by 2. Multiply both sides by 2. 8.5 multiplied by t is 8.5t. And after you multiply 2 to the left hand side, you'll be left with 0.7. Divide both sides by 8.5 and you'll get the value of t, which is 8.2 times 10 to the power of minus 2. Perfect, and that's everything for this question. If you have any questions, please let me know in the comments. Otherwise, please like the video, subscribe. I'll post a new video every day. And if you have any tutoring inquiries, just send me an email. My email is linked in the description. Thanks for watching.